going to come tell us why we need oxygen to breathe.
Yay!
Paramedic Bill!
I'm going in, girls. I'm Paramedic Bill. How is everybody today?
Good.
Shut up! That's right. All right, boys and girls, today we're talking about oxygen. We're talking about oxygen. Has 99% of room air. Tacos give oxygen.
Paramedic Bill!
What do you want, Petey?
Oxygen actually doesn't come from tacos. Actually, it says here that air has 20.9% oxygen. And Paramedic Bill, I bet you didn't know that, as this says, oxygen is the third most abundant element on Earth. Also, it has an atomic number of 8, and oxygen is needed for all life to exist.
How does oxygen get in the body? Well, number one, oxygen goes into the nose, into the lungs. And who has a better idea?
Oxygen enters the body through our respiratory structures. If in sequential order, it goes through what's called our nasal or pharynx, according to this. It then goes through our larynx, our trachea, into our bronchi, our bronchioles, our alveolar ducts, and then to our alveoli.
Thank you for the explanation, Petey. All right, number two. How does oxygen get into the blood? Well, it goes through the skin. Number two, skin. Oh, now more again. Does anybody else have a better idea?
Oxygen diffuses into blood, it says, and what happens is that's where the gas change takes place. Mrs. Davies told us about this too, and it says the alveoli capillaries provide semi-permeable membranes for gaseous exchange of CO2 and O2. In the red blood cells, O2 attaches to the heme in the hemoglobin, while CO2 passes back into the lower concentration gradient of the lungs. Also, now the oxygen is bloodborne and made available to the cells.
Okay, class, number three is glycolysis. And then Krebs cycles, it rains. Well, what did Miss Davies teach you, class?
Cellular respiration is the extraction of energy from nutrient molecules, and occurs in 3 steps. The first one is glycolysis. That's anaerobic respiration. The next one is the Krebs cycle, and you have the electron transport chain, which is the aerobic respiration. And I know you need oxygen for that because Miss Davies told us. Step 1, glycolysis.
Ooh, actually, can I explain glycolysis? Okay, well, glycolysis is a 10-step process that happens in the cytoplasm without oxygen to extract energy and an energy carrier molecule from glucose to yield energy and pyruvic acids with water. And the output is 2 NADH, 2 energy and 2 water. This pyruvic acid output can be sent to the Krebs cycle for additional energy production.
Oh, I want to explain the Krebs cycle.
Yes, you can teach it.
Krebs cycle, also known as a citric acid cycle, is a 10-step process that occurs in the mitochondria, using enzymes reactions to produce usable energy from 2 pyruvic acids and oxygen. The output is 4 carbon dioxides with a bunch of other products that are put into the electron transport chain.
Oh, can I explain the electron transport chain? The electron transport chain is also the last step of aerobic respiration, and you put in some stuff, 2 succinates, right? That's succinates, right? 2 succinate and 10 of the other things, and 6 oxygen. That's what you put in, and then his computer says electron transport chain is also known as oxidative phosphorylation, and it's the final step of aerobic respiration and occurs in the acidic intermembrane of the mitochondria. The electron transport chain utilizes electrons released from the Krebs cycle to provide the energy required to produce ATP. And so, after all of everything all put together from all three steps, the whole cellular respiration puts out 34 ATP plus 2 ATP from glycolysis and 6 CO2 and 6 H2O. Oh, that's water, huh?
Oh, yeah.
It's water, H2O. And it makes energy from the enzyme activity, but that gets absorbed by the water too.
Ah, jeez, I can't even beat myself. What's this? Oh, boy, this looks really, really neat. Clear!
Class, I can't tell you how proud I am of you. You taught us all a few things about oxygen, I think.
Oh, yeah. Yeah, you're very good, kids. Thank you very much.
We all know now that without oxygen, we cannot survive. That anaerobic respiration alone is not adequate to make enough ATP to support our life. And without our ATP and our oxygen, our pH levels would decrease, and the acidity would increase in the cellular environment, and that means we all die.
And Paramedic Bill.
Wait, you gotta tell me when you're ready.
Oh, sorry. I just want to start.
Okay, ready?
Wait, I was laughing.
Did you see my hand?
Yeah, I think just a little bit. Actually,
Okay, I gotta stop laughing first. I can't be laughing when the screen comes on.